So my flushing experiment, my new piece of kit built, and thinking about how I was going to operate this. So I decided the best way to do this was to flush it on the return on close coupled T's, and they're not strictly close coupled T's, but it's as close as I could get them. What I've ended up with is a temperature sensor down there. So if my boiler goes into hot water mode, this is a Viessmann 200, it's a 4-pipe boiler, but this one's piped as a 2-pipe, which means when it goes into hot water mode, the return water on this side can get extremely hot, and far too hot for the plastic components I've made my flushing plant out of. And so I want to limit the temperature for this flush plant to about 50 degrees. I might choose to calm it down to about 40, which is one of the reasons why I've chosen to flush it on the return. So basically what's happening here, boiler is circulating through this pipe, goes off around the radiators, around the system. As it comes back, basically it's coming off down here and coming back there. And to be fair, I think the flow rate on this system's far too high on this compared to my boiler. So if we have a look at what that's doing, that's flying around there. Now I did run this for a while across the flow and return, so I can in effect rig it up this way when the boiler's not firing. And I was getting, I run about 4 cubic meters of water through it, but now of course the flow rate around the system is going to be limited by the boiler pump, and I suspect the flow rate through my flushing plant is somewhat higher than the flow rate through the boiler. So, okay, so let me just explain a few of the bits on this. We've got the pump coming in here, which is what's creating the flow. That's coming up through this Camco magnetic filter. Now I cleaned that this morning, and I've got a problem with red iron oxide in my system. Not quite sure why. I drained this down about 6 months ago and it was clean. When I drained it down this time, it was really bad, full of red iron oxide. So obviously I didn't do any favours when I drained it down last time. Anyway, it goes out that filter across the top. It goes around the corner there, and these are all leftovers from boilers I've taken out, all these flat-faced unions. So I'm going to take an old boiler out, save those bits, and they've come in useful here. Pond filter, so this is a carbon activated pond filter. I've hot glued a temperature sensor on, a temperature gauge on here, so I can actually read the temperature off. So at the moment we've got about 27 degrees running through my machine. Then we're going through a water meter, which allows me to count the flow rate through the system. So both the flow rate and the volume. So far I've run 4.2 cubic meters of water through my filter system. Then comes through the resin bed here. So this is the mixed resin bed here. So, well, I hope it is anyway. I bought the resin on eBay. This is for making deionized water, but I'm not sure it's the right one, to be fair. But we'll find out. We'll run the experiment and find out, and if it's not the right one, I believe that's a mixed bed resin. So that then runs off up the other pipe. And when I get to here, I've got some sample points. So basically I can take a sample of water coming back from the system on this one and see what my conductivity levels are. And also I can take a sample of it coming out of my filter to make sure that I'm actually doing something and actually conditioning the water. This little unit here, I'm not sure I mentioned this earlier in the video, is my temperature sensor. And then I've got my 2 flush points with the European drain cocks again on close coupled T's going back in my return. So that's it. So we've just got to see what the results are. So now I flushed this earlier. I swear it was spotlessly clean, and I checked the conductivity and I was on 500 microsiemens, which is far too high, and I can't remember what the parts per million were, and the pH was just under 8. So anyway, I modified the installation a little bit and ran it again, and it was filthy again. So you can see there the red iron oxide is, well, I was going to say non-magnetic, and I said it on the forum the other day and someone pointed out that it's, I think it's dia something, It's only to do with the electrons. It has 2 electrons on it, and magnetic stuff has 4 electrons or something other. So this has a low magnetic. It's I don't know what words to use really. Basically, it's not as magnetic as magnetic stuff is. So the black stuff's very magnetic, and this stuff isn't so magnetic, but still magnetic enough to be collected there. So we get some idea of what's been coming back out my system. So I'm just going to leave this running. It's a weather comp boiler, so it runs all the time until it's 25 outside. Pump runs all the time. Currently it's up to temperature 35 degrees. Will be the correct temperature to maintain 21 inside my property when it's 16 outside, which is it's a little bit warmer. Feels a little bit warmer than you'd expect if it was just running at room temperature, so not cold. So that's it. We'll wait and see. We'll take some measurements and see where we come out. I've been a chance to get out the old test kit here. I've got the pH meter, conductivity meter on the go, yeah, I need to pack that up for the night actually. Anyway, I'll do another video, let you know what the results are once I've run this for a little bit.